Welcome back, everyone. In this lecture, we're going to actually code out the core concepts to extracting features from text data. So what we want to do is begin understanding the idea of how we transform raw string words into numeric information that a machine learning model can understand. And one of the simplest ways to do this is by creating what's known as a bag of words model. And recall that this is a frequency count of the words in the documents. Let's go ahead and get started by actually manually creating a frequency count or a bag of words transformation from text data to something that looks like a Pandas data frame that we could feed into a machine learning model. Keep in mind, in part 2, we'll show you the tools of scikit-learn that can actually do this automatically for you. But I think it will help you understanding if you actually do this manually one time. So let's go ahead and head to a Jupyter Notebook. Okay, here I am at the Jupyter Notebook. As a quick note, underneath the 𝒖𝒓𝒆 and NLP folder, there are two text files we have for you, one text and two text. They're also available in the data folder, and these are the two text files that I'm going to be working with. So I've opened up a new notebook here in that same folder, so I can easily access and open these two text files. So I'm coming back to this new untitled notebook, and the way you can easily open and close files automatically in Python is with the with operator. So you say with open, and then you can provide the full file path. So you could say c:// or \/ users, etc. And eventually you want to get to the file 1.txt. Since I'm in the same location, I can just say 1.txt instead of the full file path. And we're going to say with open this particular text file as whatever we want to call it. So I can say as my text. Then there's a couple things you can do here. You can read in the entire text as a string. So if we say, let's say a is equal to my text dot read, and you just have that, then a will read in the entire thing as one long string. So notice that this one long string has this \n, which recall is a signifier of a new line. And that's the way Python can keep track of new lines in the document. So when you actually print that variable a, you'll notice it doesn't show you \n anymore, it just creates a new line. So this is a story about dogs are canine pets, dogs are furry animals. Perfect. And then what we can also do, as another example, is say my text.read lines. And if you do read lines, what it's going to do is using that information of that \n for the new lines, it will actually break apart this into lines in a list. So read lines returns a list of each line. So this is a story about dogs, one item in the line, next line is its own item in the list, and then next line after that is the third item in the list. Now keep in mind, for really large text files, you may want to avoid actually displaying the output. It's not a big deal for Python to read in a large text file like this if you have enough RAM, but it may crash Jupyter if you're trying to print out an entire novel into this output cell. It'll just take forever to actually render. Okay. So that's reading in everything as a string, everything as a list. And what you could also do is be a little clever about this and read in each word separately. So if we just say read here again, recall that that produces this long string. Then what we could do is instead of saying just .read, I could say .lower and then .split. Run that, and it would essentially split up every single word. Now, we can see this is a story about dogs, our canine pets, etc., are furry animals. So that's another thing we can do here, say .lower .split to get a list of all the words in that document, which is pretty much exactly what we want to do if we're starting to think of a bag of words model. So let's begin by building out a vocabulary. And this idea of a vocabulary is extremely important in natural language processing. We have to imagine that with all the documents available for us, there's going to be kind of this limited vocabulary available. So for example, if you're dealing with something like the novel Moby Dick, there's only a certain amount of words that are used throughout that entire novel. And we can think of that array of unique words as the vocabulary for that particular document or that particular text. So what we want to do is build a vocabulary for 1.txt as well as 2.txt. So if I do the same thing here, but for 2.txt, you'll notice that now it says this story is about surfing, catching waves, etc. So there are some words that are similar between the two, 1.txt and 2.txt, and there's some words that are unique to each document. So you can kind of see where we're going here in order to eventually move on from count frequency to be able to compare the frequency of certain words between the two documents, 1.txt and 2.txt. So let's begin this process by getting all the unique words across all the documents. To do this, we're going to open both the 1.txt file and the 2.txt file, and then we're going to get a set of the unique words. So for example, we'll start off with 1.txt. So I'm going to open up 1.txt, and then I'm going to do what we just saw, which was open up my text, and then we're going to say read.lower.split. And so this will be a list of the words. So I can say something like words 1 here. And then if I want the unique words in this list, I can simply use set for this. So I will say then unique words, or uniwords1, is equal to the set of words 1. So if we run this and I check out uniwords1, then I should see the unique words. So this is a set, meaning it's a collection of unique elements, so none of these are repeated inside of the set. That's what this line up here does, converting this list that may have duplicate words into a set which removes all the duplicate words. So that's uniwords1. I'm going to copy and paste this, and let's repeat it for document number 2, 2.txt. So scroll down, paste that in, and replace where appropriate. So we'll say words 2 here, and then uniwords2, as well as here. So then when I run this, I can see uniwords2, run that, and now I can see catching, surfing, etc. So I have the unique words in document 1, the unique words in document 2. What I really need though is all the unique words across all the documents, and we can use sets for this as well. So I can simply say all unique words is equal to an empty set, and then I'm going to update this set with the rest of the other two sets. So I can say all unique words and then update this to include unique words 1. And what's nice about updating a set is, since it started off as an empty set, I've updated it to include all the unique words in item 1, and I can update it again to include all the unique words in document number 2. So we'll say unique words 2 here. Run that. And then again, check all unique words. And we can see a, about, animals, etc. And this item contains all the unique words across all the documents. Keep in mind we only have 2 documents, so this actual process is pretty easy. Now the last thing I want to do is be able to essentially assign a number to each of these words. So how can I do this? I can do it with a dictionary quite simply. I can say this dictionary called full vocab is equal to an empty dictionary, which I can just assign using the keyword. And then I'll start off a count at 0 and then do the following. I'll say for every word in all the unique words set, go ahead and assign a new key inside this dictionary. So inside this dictionary, we'll say full vocab word is equal to I, and then I'll say I is equal to I plus 1. So what this is going to do is just going to iterate over every single word in that set and then add it as an item in the dictionary and then set that equal to a number 0 and then add I or to 1. So I can see that what's going to happen is now if I say full vocab dictionary, I can see animals 0, story 1, water 2, canine 3, etc. So you may be wondering why you got a different order than what I saw here. And the reason for that possibility is because sets are not sorted or in any sort of order. So right here, this all unique words, when you iterate through it, so for word and all unique words, what's going to happen is Python's going to do this in the most efficient way possible. It's not necessarily going to do it in any sort of order like alphabetical order. So don't be confused that when you see a really small set, it could appear to be in alphabetical order when you call all unique words, but when you actually iterate through it by saying for word in all unique words and then start doing an assignment like this, it may not iterate through it in the most alphabetical way or in a way that looks sorted. Since it's just a set, it's going to do it in the most efficient way possible. So your full vocab dictionary may look slightly different than mine as far as which strings go with which numerics. But you should notice here that every single unique word now also has its unique, what we could say as an index identifier here. So let's begin or continue by creating what I'm going to say are 3 lists, which are going to start off as empty lists. I'm going to call the first one frequency, and it's going to be a bunch of zeros. So it's going to be as many zeros as there are potential unique words, which is the length of full vocab. And we're going to say the same thing for 𝒂_frequency. We're going to say zeros here times the length of full vocab. And I'll do the exact same thing for one final list called all words, which we'll use to organize all of this later. And instead of zero, it's going to be empty strings. Doesn't technically matter, it could also be zeros, but you'll see why I choose strings later on. Okay, so when you run this, notice I'm taking a single item list and then multiplying it by the length of full vocab. And what happens when you do that in Python, it creates this nice list for you of essentially a bunch of zeros. So here are kind of my first frequency counts for all the words in my actual document. And it's the same thing for 𝒂_frequency. And what I'm going to do is go through those documents, and every time I encounter a word, I'll look it up in my full vocab, take a note of the index position, such as 0, and then what's going to happen is 0 here essentially stands for the word animals, and then I'll add a count there. So this is actually pretty simple to do. What I can then do is open up those documents again. So I can say with open one.text as f, go ahead and say one.text is equal to a list of all the words in that document. So we're going to say f.read.lower.split. So when you run that, you should get a list of all the words in that document. And keep in mind these words can be repeated. Notice that dogs is appearing twice, and that's exactly what we want in this particular case. And then what I'm going to say is for every word in this document here, this one text list, so to speak, I'm going to calculate the word index by looking up that word in my full vocab dictionary. So we'll say full vocab dictionary, look up that particular word, and then I'm going to add a count at that index. So then I'll grab my frequency count list and then say at that word index, go ahead and take its current value and add 1 to it. So note what's going on with this logic. One text is this list of all the words in this document. Then I'm going to say, grab this word, such as this, and then look it up in that full vocab dictionary. So we come back up here. So in this particular case, for that very first word, this, that number that's going to be returned is 9. So full vocab, passing the string this, returns back 9. And so that word index is 9, which then says, go to the one frequency list, which recall we started off as just a bunch of zeros. Then it's going to go to index 9 and add 1 to it. It can add 1 because they're all zeros right now. And it's going to keep doing that. So then when you run this little loop and check out your one frequency document again, notice what happens. It has counts now associated with that full vocab dictionary mapping. And we're going to do the exact same thing for the other document, that is 𝒂_txt. So I'm going to copy and paste this, just going to change the names up so that it's 𝒂_txt and then 𝒂_text. Run that. 𝒂_text is now that list of all the words here. Remember, words can be repeated here. Is, that's going to be repeated. So then what we want to do is the exact same sort of thing, except we're going to add it now to the 𝒂_frequency list instead of the one frequency list. So for word in 𝒂_text, do the same lookup, except add it on to 𝒂_frequency. Run that, and now we can see the frequency, 𝒂_frequency here, and here we have it for the second document. And then the last thing I need to do is create a list that contains all the words. So recall, I made this empty list of a bunch of strings called all words. Using a very similar for loop as before, I'm going to fill this out with all the unique words in the dictionary. So what I can say then is for every word in the full vocab dictionary, so we'll say full vocab here, what I'm going to do is grab the same thing, word index for full vocab for that particular word, and then say all words. But in this case, instead of adding a count, I'm simply going to add in that particular word. So now when I check all words, it's essentially the list version of that particular dictionary. So notice the very first item is animals, and the second item is story. So animals at index 0, story at index 1, which matches up with the indices shown here, because if you go back to the full vocab dictionary up here, notice again, animals index 0, story index 1, which means I can come back down here and build a nice data frame to organize everything So we'll say PD data frame, data is equal to 1 frequency. Notice I'm passing this in as a list, 2 frequency, and then my column names, we can say columns is equal to all words. And when you run this, whoops, make sure we import pandas here. Import pandas as PD. There we go. And so when you run this, you see this nice output. And I'm going to set this equal to a dictionary, and we can call this BOW for bag of words. So BOW, and I think I said set it as a dictionary. I meant set it as a variable. Excuse me there. And we're going to zoom out just a little bit here so I can see the whole thing. So what do we actually have here? This is known as a bag of words model, which is a frequency count of all the words in the documents. And just for visualization purposes here, I've shown you all the words and then the frequency counts. So notice in the first document, animals shows up 1 time, and in the second document, animals shows up 0 times. So they're going to be similar in some aspects and not so similar in other aspects. And this is how we directly convert the string information into something numeric. And this should start kind of reminding you of something that looks similar to dummy variables, except in this case, instead of categories, we're essentially treating each word as its own separate token, and then what we can do is have those frequency counts. So this is a very powerful idea, but it's a very simple one as well. It's just count up how many times each of these unique words in the vocabulary across all the documents shows up. And you can imagine that the more similar the numbers are between documents for a particular word, the more similar those documents themselves are. Or you can use this idea with something like classification if these documents happen to be labeled. Now, before we move on to part 2, which is showing how to perform this process easily with scikit-learn instead of doing it manually, I want to introduce some concepts that we need to consider that we talked about in the theory portion lectures. Right now we have this bag of words model, but by itself, these may not actually be too helpful until we consider term frequencies as well as how often these individual words appear in the documents. If you're dealing with a bunch of documents that all happen to be part of, for instance, the same general category of a topic, for example, you're dealing with just text words in the sports section of a newspaper, and you're trying to classify things between soccer, baseball, or basketball, etc., there may be certain words that appear in all the documents. For example, run or running, since you do that in all those sports. And what you're going to have to start considering is not just is this word common in the English language, which is the idea behind stop words. So words such as this and are, those are very common across the entire English language. It could be a good idea just to remove them across all documents. The other thing we want to consider are for the particular scope of all our documents. Are any particular words showing up a lot across all the documents versus just a few documents? For example, you're not going to see the word soccer show up across all sports documents. Instead, it's only really going to show up in usually an article about soccer or football. And likewise, you may see the word run show up across all the articles in sports. And that idea of inverse document frequency and term frequency is very helpful in trying to alleviate that particular issue. Okay, so what we're going to do in part 2 is show you how scikit-learn uses this process with certain class calls as well as a sparse matrix in order to do this entire process we saw in just a few lines of code. I'll see you in part 2.